This is the video walkthrough for the review for those making up the Unit 9 exam. We're going to start with some word problems. We're going to start with, in 2010, the country's population was 3.7 million people and is growing at a rate of 2.3%. First of all, 3.7 is the starting value. That's A. So in my equation, that's going to be the A value, 3.7. But we're also told that the rate was 2.3%. So R is 0.023. Notice we moved two decimal places. B is 1 plus R, 1 plus R. So 1.023 is the B value. Next, it's going to ask us to predict for the year 2021. Remember, we started in 2010. So that means 11 years later. So when I run this through the calculator, I get 4.75 million people. And the next one's similar. We're starting in the year 2000, and an animal population started with 8970, decreasing at a rate of 7.1%. So I'm decreasing at 7.1%. Again, move two decimal places. 7.1% decreasing means a negative, and I move two decimal places. 0.071. Two decimal places. So 8970 is the starting value. That's how many animals they said we started with. B is 1 plus the rate. 1 plus this. Remember, it's a negative, so I'm going down 0.929. Here's my equation. Now it asks for the year 2025, which is 25 years later. So running this through the calculator, I come up with this number rounded to 1423 animals. Now the next problem is about a car's value. This is the equation that's given in the problem. They start us with this equation. So clearly the car started out being worth $23,000, and it's clearly decreasing in value, 0.92. What is the percent decrease? So again, B is 1 plus the rate. My B value is 0.92. So that means B is 0.92 must be equal to 1 plus R, the rate. So I'm going to subtract 1 from both sides, and R will be equal to negative 0.08. or an 8% decrease. Then it asks us to predict when the car will be worth $10,000. So $10,000 is the value of the car. Y is value. This is the time, how many years has passed. This is the car's value. So I'm going to put 10,000 in for the car's value. Now we're going to estimate this using the table app, and I'll walk you through that. We should get about 10 years. So on the calculator, we're going to take a look at the table app, and I have the function in there already. And we're going to run through and see if we can find out where it's worth $10,000. Now you can see in year 4, we're at $16,000. So let's go to like 8. We're getting closer to 10. We're at 11,000. 9, getting closer. 10, we're just about there. So approximately 10 years is the answer. Now this next section is evaluating logarithms. So I'm looking at evaluating logs in different bases and figuring out the missing exponent. Let's run through a few of these. First one is log base 2 of 8. That means that 2 is being raised to some power equals 8. Log base 2 of 8. We're looking for the missing exponent. This needs to be equal to the missing exponent. So what we're looking for is log base 2 of 8 is 2 to what power equals 8. 2 to what exponent equals 8. That's what we're looking for. So we're going to start with 2 to the third is 8. We know that to be true. We're looking for the missing exponent. So the answer must be 3. The next one says log base 25 of 1/5. So that means we're looking to find what exponent of 25, 25 is the base 25, to what power would equal 1/5. Well, we know the square root of 25 is 5. Now I'm going to ignore the fact that this is a reciprocal. I'm just focused on the 5. Square root of 25 is 5. And I write a square root as an exponent of 1/2. So the exponent must be 1/2, but the answer is a negative. Well, we also know that a negative exponent produces a reciprocal. So the reason it's 1/5 is because it was a negative exponent. Next, log base 6 of 1. 6 to what power equals 1? Well, the only thing that can give you 1 is to have an exponent of 0. So the answer must be 0 when it's a log of 1. It doesn't matter what the base is. Log of 1, answer is 0. Next one is log base 9 of 181. That means 9 to what power is 1/81? Well, again, I'm going to ignore the reciprocal. 9 to what power is 81? Well, we know that 9 squared is 81. So 9 squared equals 81. So the answer is 2. But again, remember, it was a reciprocal. 1/81. So that must mean there was an exponent that was a negative. So -2 is the answer. We're going to do one of the harder ones. Log base 4 of 8. These are both base 2. So 4 to the x equals 8. 4 to the x equals 8 means that base 2, 4 is 2 squared. In base 2, 8 is 2 to the third. So once they're both in base 2, 4 is 2 squared, 8 is 2 to the third. That means these two exponents must be equal. 2x must equal 3. So 2x equals 3 means x equals 3/2. Let's jump down to this one. Log base 8 of 2. That means 8 is raised to some power equals 2. Now, I know the cubed root of 8 is 2. So how do I write a cubed root as an exponent? Missing exponent for a cubed root would be 1/3. And the next few are just properties. E to the ln of 5x is the question. We know e and ln are inverses of each other. Exponential base e, log base e. So the answer is just 5x. Again, I have log base 4 of 4 to the 3x. These two, the logarithm and the exponential, are inverses, so they will undo each other. And the answer is just 3x. And again, I have an exponential base 3 and a log base 3. These will undo each other, and the answer is just x. These two are from the calculator. If I ask you for the log of 45, 4 decimal places, natural log of 84, and these are just the buttons on the calculator. Let me show you those real quick. On the calculator, the log button is right here. The natural log button is right here. I would just type in log of 45, log of 84. There's my decimals. Alright, let's do the next part. This is about the inverses. So what I'm looking at is finding the inverse for logarithms and exponential functions. And the first couple, I already have the answers written. We'll talk through it, and I'll do the last two with you. So first of all, I have f of x equals log base 3 of 1/3 x plus 7 log base 3. That means I have an exponential in base 3. So the inverse of a log in base 3 is an exponential in base 3. Log base 3, exponential base 3. Now, the exponent was a 1/3. Sorry, inside the parentheses of the logarithm is a 1/3. So that means I'm dividing by 3 inside with x. So we're going to multiply by 3 on the outside. Outside means out in front of the exponential. In the logarithm, I had a plus 7. That's outside. So I'm going to go inside, and again, inside means inside the exponent for an exponential, and I'm going to do minus 7. Plus 7, minus 7. We change the sign, or the operation, do the inverse operation, and we change where it is in the problem. So on the next one, 24, I've been given negative 6x minus 5 is the exponent minus 3. This is an exponential in base 6. So the inverse would be a logarithm in base 6. Now I have a negative on the outside. That means a negative on the inside. I have minus 3 outside, plus 3 inside, minus 5 inside, plus 5 outside. Again, think about the transformations. Could be helpful. This transformation is down 3. Well, equivalent to down 3 would be going left 3. Equivalent of right 5 would be up 5 when we do the inverse. So let's walk through this next one. 25 is y equals 7e to the x minus 4. So e, that's an exponential in base e. So I want log base e, which is ln x. So ln x would be the inverse to exponential base e. Now I have a times 7 on the outside. It's a vertical stretch by 7. Well, if I'm going to multiply by 7 on the outside, I would have to divide by 7 on the inside. So we're going to create a parentheses here, and inside the parentheses, we're going to divide x by 7. Vertical stretch by 7, horizontal stretch by 7. Now this is a minus 4. So a minus 4 inside the exponent is equivalent to plus 4 outside. And again, right 4 matches up with up 4. Now let's do ln. This is a log base e, so I want an exponential in base e. I'm going to go e to the x power. That's the inverse to log base e, or ln x. Now this is plus 3 inside, so we're going to go minus 3 outside. This is plus 8 outside the parentheses, so we're going to go minus 8 inside. Or think about the transformations. Left 3, down 3. Up 8 would be equivalent to going right 8. That's the inverse function. All right. Next section is going to ask us to graph and identify transformations. We're just going to do a couple of these. Let's start with number 27. It gives us an f of x of 3 to the x, and it gives us g of x is 3 to the x minus 2 plus 4. So we're changing two things. We're moving right 2 and we're moving up 4. Okay, so first we're going to make a chart for the parent function 3 to the x power. So this chart, again, we're going to go negative 2, negative 1, 0, 1, 2, just like we always do for exponential. Center point is always 0, 1. I multiply by 3 this way. That's what base 3 means. And this way I'm dividing by 3, so 1/3 and 1/9. That's the parent function. Now if I draw that parent function, that means from negative 2 on x, negative 2, I'm going to be at 1/9. Very, very small. Negative 1, I'm at 1/3, still very small. 0, I'm up at 1, center point. 1 comma 3, and 2 comma 9. And 9 would be way up here. It's growing exponentially. This way it's coming down, and it's decaying exponentially going backwards to the left. Remember, this is following an asymptote y equals 0, getting ever closer to 0. Now this, we can do our transformations, but remember, we can always just take an exponential and center it around h. H in this case is 2. It moved right 2. This whole thing shifts to the right 2. So instead of it being centered at 0, now centered at 2. So I have 0, 1, 2, 3, 4 is the ones that make the most sense. Now, 2 is the movement right. So all those x values went up 2. The y values moved up 4. So all these y values are going to move up 4. So we're going to move all of them up 4. 1 plus 4. We're going to take 1/3 plus 4. 1/9 plus 4. 3 plus 4. 9 plus 4. And this is going to make my new function. Means 0, I'm at 4 1/9. At 1, I'm at 4 1/3. At 2, I'm up at 5. By the time I'm at 3, I get all the way up to 7. So we're getting up here. So this is growing, same way as the other one did, growing exponentially, coming down and approaching an asymptote, but we move the whole thing up 4. So my asymptote, if I can get in line here, is going to be at 4. So this graph is approaching a y value of 4, and you can see that in the numbers. It's getting closer and closer to 4. Domain for this, domain for all exponential goes left forever, right forever, all real numbers. The range, well, it's not going to go below 4. It's not even going to reach 4. So everything greater than 4. Alright, let's do 29. Let's do a logarithm. So what I have is log base 4. Now this is the same thing as an exponential in base 4, only x and y have switched places. So an exponential base 4 would have x values that go from -2 to +2. Well, this is log base 4. So it's the y values that go from -2 to +2. And then base 4 would go 1, 4, 16 times 4 this way, always starting at 1, dividing by 4 this way. That's base 4 pattern. But we're doing logarithms, so x and y are switched places from what an exponential would look like. Now when I graph that, 1/16, it's very small. We're going to have to go out to 4. I'm not going to go all the way out to 16 on the x. We'll just go to 4 for now. So 1/16, very small, comma -2. So 1/16, very, very small. We're going to be down at -2. 1/4, still pretty small, -1. Center point 1, comma 0. There we are. 4, comma 1. So 4, comma 1. And then the next point would be all the way out at 16 off the paper. So we're not going to draw it. And it's going out to that 16. Coming down, and oh, that's right, getting very, very close to what? Closer and closer and closer to an x value approaching 0 is the asymptote. Now, g of x, a couple things have happened. First of all, I've stretched it by 2 and reflected it around the x-axis. So that changes y, -2. So these y values are going to be multiplied by -2. Multiply all the y values by -2. Okay. And then I'm moving left 3. So I'm taking all of these and I'm subtracting 3. So that's going to be at -2 15/16. -2 3/4. Again, -3. 1 minus 3 is -2. We're getting closer and closer to -3 here. Now we're getting away from that. So 4 minus 3 is It's 1. 16 minus 3 is 13. Again, this is moving left 3. So we're subtracting 3 from each of those x values. This is a vertical stretch by 2. Reflect the y-axis. And we're just going to take that. It's going to stretch it. So we're going to be getting all the way up to 4. All the way down to -4. It did flip it also. And we're moving the whole thing left 3. So let's get that center point. -2, 0. Let's also get my asymptote here. The whole thing moved left 3. Notice x is getting closer and closer to -3. So here at -3 is my asymptote. And it's doing that when y is 4 and 2 because we flipped it around. So at 2 and at 4 is where it's getting closer and closer and closer. And at 1, I'm at -2. 1, -2. You can see it's starting to grow exponentially in the x direction. It's going to hit that point. If I can get the point, there it is. And it's just going to keep growing. I'm not going to plot the last one. Domain for this guy is it goes forever up, forever down. Well, that's the range, is all real numbers. Domain for this guy, it's never going to reach that -3 line. It's going to go to the right of it, but it's never going to reach -3 or go below it. So x has to be everything greater than -3. All right, almost done. Last couple, we need to take a look at the paper for this. So first of all, number 31, let graph of g of x be a reflection in the y-axis followed by a translation 4 units up and stretched vertically by a factor of 3 of f of x equals 2 to the x. So in other words, it says 2 to the x is my f of x, and I want to reflect the y-axis. Well, reflect the y-axis, that's a negative inside. Then it says followed by going 4 units up, 4 units up, outside, and stretched by 3. That means I'm going to take this whole thing and stretch it by 3. So that's going to be that stretched by 3, but also this term is being stretched by 3, making it 12. Now, I start with log base 1/3 of x, and it says let the graph of g of x be a translation 4 units left, followed by a horizontal stretch by a factor of 5 of the graph log base 1/3. So starting with log base 1/3, it wants to go 4 units left. 4 units left, that's inside, and left would be +4. We do the opposite. Then it says a horizontal stretch by a factor of 5. So I'm going to take this and I'm going to horizontally, stretch, that's 1/5 because I do the reciprocal for a horizontal. So not by 5, but actually the number 1/5 is being multiplied by x inside. And that concludes the video recording for the review. Please make sure that you log in to the post and look at the other review. There will also be a picture of the answers for that other review that you can do to practice. When you are done with that and you feel comfortable, let me know, and I will send you the exam to get this made up.